Single phase, three phase. It is at this point we can start to discuss the single phase and three phase electrical interfaces. The single phase connection to the three phase grid demonstrates an imbalance, but happily, this imbalance is relatively limited. Adjacent feeder stations use different phase combinations. This is largely because the three phases can be out of sync as the power is generated. For those viewers who are new to the concept of single and three phase, and also for those who would like to know more about phase cancellation, let me explain. Here you can see a waveform. It oscillates between positive and negative, cycling or alternating between plus and minus. This represents alternating current. In the UK, we expect to see 50 alternating cycles every second. This is what we mean by 50 Hz. There is only one single waveform being shown here, and whether the voltage is 110 volts, 220 volts, or 2 million volts, the number of cycles still remains 50 per second in this country, and this single waveform is referred to as a single phase. Now, if we were to introduce another waveform, slightly after the first, we would have a second phase. Both are operating at 50 Hz, but one phase is starting slightly after the other. If we add one more phase, then we have three phases, all operating at 50 Hz, all slightly staggered in time. And why do we want this? Imagine a single-cylinder petrol engine. If you can get it to run, it will run in a fairly lumpy way. Each detonation of the petrol forces the piston down, rotary motion is achieved, and after the exhaust gases are blown out, the piston is ready to fire again. But this is a very lumpy operating engine. With three cylinders, you can achieve a much smoother transmission of power, which is easier on all the mechanical parts and makes for a much more comfortable ride. The same is similar with electrical motors. Lots of little nudges would be preferable to one hard whack. Sometimes single phase is good enough, if you're using an electric drill, toothbrush, hairdryer, or washing machine, for example. We don't need to go to the trouble and expense of heavy three-phase motors, but where you want heavy-duty, reliable, low-maintenance power, three-phase is the way to go, and this is what is used in electric road vehicles, such as the ones Tesla, Honda, and Ford produce. So now you know what single and three-phase electrical supplies look like, and why one might be preferred to another. Let's move on to phase cancellation. For this, we're going to look at a simple single-phase waveform, as it's easy to see what's going on. But exactly the same thing will happen with three-phase, as I'm about to show you. Imagine a substation supplying power to a section of rail which is being used by one of our electric trains. The substation cannot provide power for the entire journey of the train, which might be, let's say, 150 miles. So other substations are used along the journey to keep the necessary voltage levels where they need to be. The substations will produce electricity independently of each other. They are not synchronized in any way. So, if substation A produces a 50 Hz waveform that looks like this, and substation B produces a 50 Hz waveform that is 180 degrees out of phase, you get this. The plus and minus voltages will cancel each other out. This, by the way, is exactly the same technique used for active noise-cancelling headphones. A positive sound wave is met with a mirror image of itself, cancelling out the sound signal. But back to our electrical substation problem. How do you prevent one substation's output from interfering with another's? The answer is, you isolate one from the other. We use a neutral zone, a small gap between one provider of power and another. As long as the train never stops underneath this small gap, the momentary interruption of electricity supplying the locomotive will go unnoticed. The forward momentum of the speeding train will allow it to simply glide through the neutral zone, and the whole thing works seamlessly. This workaround is referred to as phase disconnection, and you will throughout the course of your career hear about phase disconnectors and neutral zones, and these are the same thing, a simple break in the supply of electricity from two supply sources.